A ruby is a pink to blood-red colored gemstone, a variety of the mineral corundum, aluminium oxide. Other varieties of gem-quality corundum are called sapphires. Ruby is one of the traditional cardinal gems, together with amethyst, sapphire, emerald, and diamond. 3. The word ruby comes from rubor, Latin for red. The color of a ruby is due to the element chromium. Some gemstones that are popularly or historically called rubies, such as the Black Prince's ruby in the British Imperial State Crown, are actually spinels. These were once known as Balas rubies. The quality of a ruby is determined by its color, cut, and clarity, which, along with carat weight, affect its value. The brightest and most valuable shade of red, called blood red or pigeon blood, commands a large premium over other rubies of similar quality. After color follows clarity, similar to diamonds, a clear stone will command a premium, but a ruby without any needle-like rutile inclusions may indicate that the stone has been treated. Ruby is the traditional birthstone for July and is usually pinker than garnet, although some rhodolite garnets have a similar pinkish hue to most rubies. The world's most valuable ruby is the sunrise ruby. Rubies have a hardness of 9.0 on the Mohs scale of mineral hardness. Among the natural gems only moissanite and diamond are harder, with diamond having a Mohs hardness of 10.0 and moissanite falling somewhere in between corundum, ruby, and diamond in hardness. Sapphire, ruby, and pure corundum are alpha alumina, the most stable form of Al2O3, in which 3 electrons leave each aluminium ion to join the regular octahedral group of 6 nearby O2- ions. In pure corundum, this leaves all of the aluminium ions with a very stable configuration of no unpaired electrons or unfilled energy levels, and the crystal is perfectly colorless. Crystal structure of ruby showing the substitution of Al3+ ions, blue, with Cr3+, red. The substitution density of Cr3+ ions in this model is approximately 2%, approximating the maximum doping normally encountered. 4. When a chromium atom replaces an occasional aluminium atom, it too loses 3 electrons to become a chromium 3+ ion to maintain the charge balance of the Al2O3 crystal. However, the Cr3+ ions are larger and have electron orbitals in different directions than aluminium. The octahedral arrangement of the O2- ions is distorted, and the energy levels of the different orbitals of those Cr3+ ions are slightly altered because of the directions to the O2- ions. 5. Those energy differences correspond to absorption in the ultraviolet, violet, and yellow-green regions of the spectrum. Transmittance of ruby in optical and near-IR spectra. Note the 2 broad violet and yellow-green absorption bands and 1 narrow absorption band at the wavelength of 694 nanometers, which is the wavelength of the ruby laser. If 1% of the aluminium ions are replaced by chromium in ruby, the yellow-green absorption results in a red color for the gem. 5. Additionally, absorption at any of the above wavelengths stimulates fluorescent emission of 694 nanometer wavelength red light, which adds to its red color and perceived luster. After absorbing short wavelength light, there is a short interval of time when the crystal lattice of ruby is in an excited state before fluorescence occurs. If 694 nanometer photons pass through the crystal during that time, they can stimulate more fluorescent photons to be emitted in phase with them, thus strengthening the intensity of that red light. By arranging mirrors or other means to pass emitted light repeatedly through the crystal, a ruby laser in this way produces a very high intensity of coherent red light. All natural rubies have imperfections in them, including color impurities and inclusions of rutile needles known as silk. Gemologists use these needle inclusions found in natural rubies to distinguish them from synthetics, simulants, or substitutes. Usually, the rough stone is heated before cutting. These days, almost whole rubies are treated in some form, with heat treatment being the most common practice. Untreated rubies of high quality command a large premium. Some rubies show a 3-point or 6-point asterism or star. These rubies are cut into cabicons to display the effect properly. Asterisms are best visible with a single light source and move across the stone as the light moves or the stone is rotated. Such effects occur when light is reflected off the silk, the structurally oriented rutile needle inclusions, in a certain way. This is one example where inclusions increase the value of a gemstone. Furthermore, rubies can show color changes, though this occurs very rarely, as well as chatoyancy or the cat's eye effect.